Assalamualaikum warahmatullahi wabarakatuh. So our group choose temperature control of a room as our optimal control problem. In this case, we want to control the room temperature so it stay close to the desired value while using minimum heating energy. This is considered of an optimal control problem because we can adjust the heater power, which is our control variable. The room temperature changes according to physical law and that represent the system. Our goal is to find the best way to control the heater so that the temperature remains ideal and the energy use is minimized. So basically, we are finding the most efficient control strategy to achieve the desired temperature with the least cost.
The first basic element of an optimal control problem is the control system, which describes how the system evolves over time when we apply a control input. Mathematically, it is expressed as x by t equal to fxt ut t. Here, xt represents the state variable. In our example, it is the room temperature. The control variable ut is something we can change. In this case, we can take the heater power. This equation tells us how the state changes depending on both the current temperature and the control we apply. For instance, when we increase the heater power, the room temperature rises faster. When the outside temperature drops, the system needs more control input to maintain comfortable. So, the control system forms the foundation of any optimal control problem because it defines the relationship between what we control, ut, and how the system responds, xt.
For the second basic element, which is cost of functional, Ju, the formula is Ju equal to integration of L function, which is running cost, plus K function, which is terminal cost. The cost of functional is basically a formula that can measure our system performance where we put and apply a certain control into the system. It will tell us how to minimize or maximize our energy, time, and error. But for this application, we want to keep our room temperature close to the desired level, even though in the minimum energy. So for the cost of the functional, we have the desired room temperature, the penalty if temperature differs from target, and penalty if using too much energy.
The output of an optimal control problem includes two key results, which is optimal control, U star t, and the optimal trajectory, X star t. These represent the best possible control action and the resulting system behavior that minimizes the cost functional. In the temperature control example, the optimal output gives us how much power the heater should use over time to maintain the desired temperature while consuming the least energy. This output reflects the harmony between system behavior and performance goals. That's all from us. Thank you.